In lesson 7-7, there's going to be a couple patterns we'll notice when we are multiplying or factoring trinomials. So, for example, they use letters here, which makes it confusing. But let's look at an example here. We have x squared plus 14x plus 49. Notice that 49 is kind of a special number. That's what 7 times 7 would be. So the pattern is going to be that if 7 times 7 makes 49, what's 7 plus 7? 14. So there's certain trinomials that have patterns. Now, one thing I can't stress enough is that you can still do these with your generic rectangles like the normal factoring. So x squared would go in the top left, and I have x times x. 49, my last term, would go in the right bottom box. I would be thinking, what two numbers could I multiply to get 49, but add to 7? Or add to 14, rather. If I put a 7 here, I'd have 7x. And if I put a 7 here, I have 7x. So my factored form will be x plus 7 times x plus 7. Another way to write that is x plus 7 quantity squared. It's a perfect squared trinomial. So now, if we look at part B, notice that 9 is a perfect square and 25 is a perfect square. Again, if you didn't see this pattern, there's nothing wrong with just doing the same old 9x squared in the top box here, 25 for your bottom right box, and because this doesn't have an a value of 1, we could use our diamond, and we need 9 times 25, which would be 225x squared. Kind of a big number there, but we can still use the same process. And of course, add to negative 30. We need these two numbers to add to negative 30x. So if we think what two numbers would multiply to 225 but add to negative 30, I might be here a while saying, well, that's 1 times 225, or that's 9 times 25. I have a lot of factors to think about. What I wanted to come over here and think, when you have perfect squares, I could do 3x times 3x and get 9x squared. And I could get 5 times 5 to be 25. But if I take 5 times 3, I get 15x. And a 5 times 3, I get 15x. I'd want them both to be negative in order to make my negative 30x happen in the middle here. What did that mean? Negative 15x times negative 15x would have been the factors I wanted to multiply to 225 but add to negative 30. So it's kind of a shortcut if you see perfect squares like 4, 9, 25, 36 to help you, because our factored form will be 3x plus 5 times 3x plus 5, or 3x plus 5. Oh, I'm sorry, those need to be negative 5s here. Let me make that edit real quick. I need the negative 5 to make a negative 15, so it's 3x minus 5 on both of these. Those would be my factors, which I could also write as 3x minus 5 quantity squared. Down here's my final answer. It's always okay to go back to your regular factoring method and use your diamond here. It's just that this was a really big number. If you could see the pattern, you'd be able to factor it maybe a little bit quicker. So let's try one more. I've got a 4x squared. Let's see if we can follow this shortcut. 4x squared and a 9. They're both perfect squares. So 4x squared would be 2x times 2x, because 2 times 2 is 4. To get my 9 in my bottom right one, I'd have 3 and 3. It's always worth a check. What's 3 times 2x? That would give me 6x. What's 3 times 2x here? Another 6x. Did I get my 12x like I wanted? Sure did. My factored form would be 2x plus 3 times 2x plus 3. Or, if you had to choose, it could be written as 2x plus 3 squared. Part B, same idea. This one actually is a little bit smaller, but 1 times 1 is 1. That's a perfect square. And then for my 16, 4 times 4 makes 16. But this time, I want it to be a negative 8. So I have 4 times 4 to make 16, but I'm going to make them both negatives. Because then I'll have a negative 4x and a negative 4x to make a negative 8x. My factored form would be x minus 4 quantity squared. Here we have x squared and 64. Your box could work here. So I've got my x squared and my 64. Notice it's perfect squares again, so I'm going to try it with a pattern. X times x makes x squared. 8 times 8 makes 64, so I'm going to go 8 times 8. This time, though, and I forgot down here, this is a negative 64. Even I forgot the rule of take the sign with you. I need one of these to be a negative and one of these to be a positive 8. This works out wonderful when I have a negative 8x and a positive 8x. Those two terms will cancel and make 0 because I don't want a middle term. So my factored form is x minus 8 times x plus 8. Same thing here. If I've got my box, I notice that 9 and 100 are both perfect squares. So if I put my 9x squared in the top left and my negative 100 in the bottom right, I'm going to try my factors of 3x and 3x. And then my 100 could be 10 times 10 to make these add to 0. How about a negative 10 times a positive 10? Well, that would mean 10x is here and minus 10x is here. They would cancel out when I add them together to make 0 x's. And I don't want any x's, and I still get my negative 100. So 3x minus 10 times 3x minus 10, or 3x minus 10 squared. Nope, just kidding. 3x minus 10 times 3x plus 10. Wrong pattern here. Would be my factored answer. You can do try it for, same thing. If you can notice, sometimes you still need to use that GCF. I could take a 4 out of all of those and an x, and I'd be left with x squared plus 6x plus 9. Right in here is another perfect square. That GCF will always make your factoring easier. So I'd have x times x and 3 and 3 to add to my 6x. My final answer would be x plus 3 times x plus 3. But you can't forget that GCF you took out in the beginning, which is a 4x. There's your final factored form. Same thing here on try it B. Check your answer key, but you're going to want to take out what 50 and 32 have in common. So the formula might be, if you ever had an a minus b times an a plus b, it would be a squared minus b squared. Or if you had a plus b times a plus b, we also write that as a plus b squared. It'd be a squared plus twice your ab plus your b squared. These formulas may be worth memorizing, but they're just kind of patterns. As we said, you can always go back to using your generic rectangle to factor. And remember to always take out a greatest common factor if all three of your terms have it. That will bring down the multiplying that you need to do.